I can't think of any more worthy recipient of the Manning Award, or the principal Manning Award, than Lorne Tyrell. There's no question that his contribution merits recognition at the highest order.
I was extremely surprised and very, very honored when Dave Mitchell came in and said that I was the principal winner of the Manning Award this year. That was a very special moment.
Dr. Lorne Tyrell is renowned for his pioneering work in the discovery of antiviral agents against hepatitis B and transforming those discoveries into an affordable new treatment used the world over. A former dean at the University of Alberta, Dr. T continues to teach, mentoring his students to find absolute cures for both hepatitis B and hepatitis C. Dr. Lorne Tyrell, recipient of the $100,000 Encana Principal Award.
Hepatitis B virus causes chronic infection of the liver. There are approximately 350 million people in the world that have chronic hepatitis B. About 1.4 million people per year die from the complications of hepatitis B. The disease is transmitted from mother to infants at birth or sexually transmitted. It is also transmitted by IV drug use or contaminated blood products. The traditional way of treating hepatitis B was to use interferon, and interferon is difficult to utilize. You have to take it by needle. It causes severe side effects, and it was very expensive. I had a number of patients that were really dying of chronic hepatitis B, and I saw some of them really get a new life when the hepatitis B therapy became available. The real innovation came from the fact that there was no way you could grow hepatitis B. And we discovered the ducks were a model, and the duck virus we thought would be very similar to the human virus, and we used liver cells from infected ducks to grow the virus in cell culture and screen compounds for hepatitis B. Once we had the ducks, we could culture liver cells from young ducklings, and as they grow in culture, you can add selected antiviral agents to see if they have an effect on the virus. Once we had the ducks and we were able to show a compound was active in ducks, we wanted to check it against the human virus in a chimpanzee. We found chimps that were carrying chronic hepatitis B, and we used those chimps in these studies. We didn't have to infect any chimps for the studies on hepatitis B. These chimps were trained to drink Tang, young chimps, and we spiked their Tang with our drug, and they began drinking it, and every 2 weeks we increased the dose. And when we went back and analyzed these results, we found even the lowest dose we used had a marked effect on the amount of virus in the serum. And the virus disappeared rapidly. You know, we have to go from chimps to humans. And we planned the first clinical trials to be done here in Edmonton, in Johns Hopkins, and 3 sites in Europe. And we brought in 76 patients, and we treated them with different doses of the drug. And we found that all of the patients that got more than 100 milligrams of the lamivudine showed a marked decrease in the amount of virus in their blood. It decreased by 99.9%.
Lorne has given the world a great gift. On the same scale as antibiotics, as the introduction of insulin, it is a huge leap forward in medical knowledge and in therapy for patients. It is a very big deal.
We really knew that we had something that was going to work for patients. So we went to several drug companies. Glaxo, after we made the presentation, within 20 minutes, they had the president down to see us. And they said, we're going to work together. And really, this could not have happened without Glaxo and all of the effort they put in. Perfect example of industry, university, government working together to make something truly important happen.
We can carry out life-saving liver transplantation in patients with end-stage hepatitis B. We couldn't do that before this drug.
Patients with hepatitis B before this innovation were eliminated from that option simply because their livers got reinfected right after they were transplanted, and often they had a very aggressive disease. So transplantation programs were shutting these patients out. With the innovation and the presence of lamivudine, we once again opened that option to many patients. That group of patients then had that treatment option. They never had it before. We did the first transplant using our drug pre- and post-transplant here in Canada, the first in the world, I believe. And that was clearly a patient that could not have been transplanted, would have died, and he went on to a very successful transplant with no evidence of the virus for many years.
Without this drug, most likely with the way it was going, my liver, I would probably develop liver cancer or cirrhosis. The drug is called Heptovir, and basically has given me confidence in my future for a longer life, and hopefully cancer-free or cirrhosis-free. I'm doing great, doing great.
This drug is available. It is now distributed worldwide, and it can treat the patients that have got progression of their disease. We look for patients that have got more serious disease and is progressing, and these are the patients that are getting the drug first. Yeah, I think it was truly pioneering that this was the first antiviral of this type that was used in the treatment of hepatitis B. So it's called the first generation antiviral of this class. There will be a second and a third generation that will be improvements on it, but it was the pioneering discovery. And I really believe that both hepatitis B and hepatitis C can be cured diseases and cured in our lifetime. I've won a number of awards, but this one is very special.